All right, enough fooling around on this 85, enough teasing. Let's take a look and see a couple of places where we can usually spot this AD. One spot where we usually can and one spot where we always can. We know that this summary route, when R2 gets it, it went in the table as an EIGRP route, as we would expect, and it had an AD of 90. That's the value we expect it to have because the summary is only going to have that AD of 5 on the router doing the summarization. But then when we looked at router 1, we didn't see an AD. Let me bring that up. I believe I was messing around with the config there a little bit during the break, or just looking around. Didn't change anything. Let's have a quick look at that just as a reminder. And we look at it right in the middle. It is an EIGRP route, so if we ran show IP route EIGRP, we would see it. And it's been in there for 23 minutes, 17 seconds. We know all about the null 0, but there's nothing in there as far as an AD of 5. So where the heck can we see it? Well, if we expand on the show IP route command a little bit, we can spot it. And then we're going to put the mask. And then we're going to stop. And you can see right here in the middle of the second line, distance 5. That's where you can always spot it. Just run the show IP route command, but go ahead and put in the network name and, the network and the mask for the summary instead of just looking at the entire routing table. Another place you can usually see it is in your actual config, and here it is. Remember when I mentioned it's a good idea to know what the heck this 100 is in the middle of this, and we know that it's the EIGRPAS? Well, usually when you look at the IP summary address command in your config, it's going to stick that 5 on the end of it, even though we didn't enter it. And that, of course, is going to be the default AD for that summary. And it is changeable. It's very rare that you're going to do that, so we're going to leave that alone. But you can't always see it here. You can usually see it here. I would depend on the show IP route command to always be able to see that particular value. So let's go ahead and bring that down and talk about a related topic. We're going to chat about it for a few minutes and then see it in action. And that is EIGRP stub routing. This is a fantastic way to do several important things. First off, it really helps us keep our table complete but concise by limiting the size of some routing tables in the EIGRP network while at the same time limiting the scope of queries. Now, those of you familiar with OSPF stub routing, you're already hitting your head on the desk saying, oh no, we've got those stub areas and then we've got total stubs and not so stubby stubs, and I know people always think I make that last one up. EIGRP does have some important options and defaults we need to know, and we'll see some of those in action. But we don't quite have the complexity, I should say, I wasn't going to say craziness, but complexity that OSPF has with its stub areas. Now, a good time to use stub routing is in a hub and spoke config like the one we've been using throughout the course. Because whether we're looking at this from R2 or R3's point of view, the next hop IP address is always going to be what? 172.12.123.1. Because there's no other option. There is no other possible next hop IP address in the network that we've used so far. There could be 75 networks connected to router 1 and or router 3, and packets sent by R2 to any of those will always have the next hop IP address 172.12.123.1. We saw that in the previous video before we did the route summarization. Router 2 had a route to every one of router 1's loopbacks, but again, the table, was already 7 routes big, but what was the next hop IP address? 172.12.123.1 for every single one of them. So stub routing helps us bring that table size down, and it also brings us some other advantages. The first one is the one that I really love. When an EIGRP speaking router loses a successor and no feasible successor is known, we know what happens then. The dual query process goes into action. The router that lost the successor starts sending dual queries out to its neighbor saying, hey, do you have this route that I just lost? Well, that router will not query stub routers. So that knocks back on our traffic already, and it does limit the overall scope of query packets. Now, by default, EIGRP stub routers advertise information about 2 route types back to the hub. directly connected networks, and summary routes. That's it. Directly connected networks and summary routes. Good stuff to know. Now, only one router in a given adjacency can be a stub. Two routers, both configured as an EIGRP stub, they cannot form an adjacency. And to form an adjacency, we're going to use the EIGRP stub command. And this is a router command. It's not an interface deal. And to change the default route advertisement we talked about a moment ago, we're going to use that same command followed by the route types you want the stub to advertise to the stub. And there's going to be a leak map option. We're going to leave that alone for right now. And at the beginning of the very next video, we will work with an EIGRP stub router or two. I'll see you there.